Welcome to the 3030 Health Podcast. The following discussion is for education and entertainment. It is not intended to diagnose or treat disease. Please do not apply any of this information without first discussing it with your doctor. Here is your host, Dr. Ruiz.
Hello everyone, super excited about my guest today. My guest today is Anthony Basile. Anthony is a new graduate student in the evolutionary biology PhD program here at ASU. He's originally from New York and earned his Bachelor's of Science in Dietetics, Food and Nutrition from City University of New York, Lehman College, and his Master's of Science in Human Nutrition from Columbia University Medical Center. Additionally, Anthony is a nutrition and dietetic technician accredited from the Academy of Nutrition and Dietetics. Anthony also serves as a board member for the Ancestral Health Society, and he is an associate editor for the Journal of Evolution and Health. We talked about new studies, his research, and some really cool conversations about evolutionary theory. Also, be sure to check the new summit, Health Hackers FX. I was invited to be one of their presenters, and we discussed really cool information about thyroid health. I hope you enjoyed the show. Hello everyone, super excited to have here one of my friends here in the Valley and a really cool guy that is super active in the research side of the ancestral movement. Anthony, how are you doing, man?
I'm doing great. Thank you so much for having me.
Dude, we've been talking and over email and texting and, for quite a while now. And we finally made it happen after all this crazy misconnections and technology flaws. We finally get to talk, man.
I think what's even funnier is I live literally 5 minutes drive from where you live.
And that's what's super hilarious. I met Anthony through the Ancestral Health Society, the Ancestral Health Symposium. He is one of the board members of the whole conference, and you're an editor for the journal, aren't you?
Correct.
Pretty cool guy, and he ended up, I'll let you tell the story. So for anyone that doesn't know your work, Anthony, what is your hero story? How'd you end up in this movement?
Oh, I don't know. About 7-8 years ago at this point, I was trying to lose some weight, and I was working in a pharmacy at the time, and the pharmacist was like, "Hey, have you heard of the paleo diet?" And they told me about it, and I was like, "That sounds stupid." So then, after some pushback, I finally gave it a shot, and it worked miracles for me. Lost a lot of weight, turned around my health, and then, I just loved it so much, I went back to school to study nutrition. Got my bachelor's in dietetics and nutrition from CUNY Lehman College in New York. Then I got my master's from Columbia Medical. And then currently I'm a second-year evolutionary biology PhD student at Arizona State University.
That is insane. Has it really been a year?
Yeah, just going into my second year already.
Dude, I just finished my first year of residency, going into my second residency. So yeah, it is a year.
Time flies.
Yeah, and you are working on some really cool stuff with birds at ASU. Can you tell us a little bit about what you're doing?
Definitely. So in my lab, I work with Dr. Karen Swayze, and we are interested in using a comparative physiology perspective. And I like to think of that as a physiology-first perspective. So you're interested in a problem or a question or a physiological process, and then you pick which animal model you can use to best answer whatever question you're looking at. So in our lab, we use birds, and birds have the highest blood glucose values of all animals. So actually looking at this table that's directly in front of me, from the Phoenix Zoo, we got a bunch of blood samples, and birds sit up around 16, 17 millimoles of blood glucose, and humans sit down around 4.
Yeah, so can you translate it to what a glucometer would read?
Oh, I don't know, 400?
Yeah, in the 400s.
It's high, yeah. And so basically they're naturally adapted to having this high blood glucose concentration, and they have none of the diabetes-like complications that mammals get from having hyperglycemia. So we're trying to figure out what is going on and with them. A, how are they able to maintain this without any complications? And B, just evolutionarily, why is it so high in the first place? And we're doing some cool studies. We're doing some dietary interventions in the birds to see how they respond. And pretty much the conclusion of just about everything we do is that birds are weird, and we're still trying to figure them out.
And we've had a couple of conversations about this topic, and something very interesting that you mentioned was that birds don't have GLUT4 receptors. Now, for the people that are listening, what are GLUT4 receptors, and how do they? Why are they important for humans?
So GLUT4 is the glucose uptake transporter that is responsible. So when insulin binds to an insulin receptor on insulin-sensitive tissues such as muscle, fat, or the liver, it then tells the cell to go ahead and take blood glucose out of the blood and bring it into the cell to use it, either use it for energy or to store it or convert it, however. And GLUT4 is the actual transporter that takes the glucose out of the blood. So insulin does work in birds, but so they don't specifically have a mechanism to allow insulin to decrease blood glucose. Crazy weird. Crazy weird.
So birds do have insulin, and do you know off the top of your head, if the insulin levels in birds are around the same number as the insulin levels in humans?
In humans, it would be a tough comparison. So typically in the lab, we like to think of birds compared to rats or mice, because that's typically one of the most common animal models used. And I can't tell you off the top of my head, but I want to say that it runs lower simply because of the fact that they don't have the GLUT4 receptor. The main function that we often associate with insulin doesn't work in birds. So actually, glucagon is like their main fuel regulatory hormone. So glucagon does a lot more than insulin in the birds.
For the people listening, what's the difference between insulin and glucagon?
So insulin through that pathway will lower blood glucose, and glucagon will work to increase blood glucose. So there's just think of them like a seesaw, and they go back and forth to maintain blood glucose. In mammals and humans, in birds, that seesaw ride is a little wonky between the two.
This is fascinating because if you follow a ketogenic diet, or if you've heard of a ketogenic diet, or even, within the ancestral type of diet, you always think that you want to keep your sugar levels as low as possible. And in humans, at least, the way you do this is by by trying to keep those GLUT receptors satisfied, I guess. So if you have high levels of glucose in your blood in a person with type 2 diabetes, evolutionarily, those GLUT receptors get switched off. And then you start accumulating glucose in your bloodstream. And in theory, what we, in pop, medicine that you would hear from, your friendly Facebook chat, having these high levels of glucose in your blood is really corrosive, and it wreaks havoc in your veins and in your arteries, and that's why you create damage and you can have heart attacks. And yet, in the model of a bird, or in a bird's physiology, they have super high levels of glucose in their blood, and nothing is happening to them.
Correct. You ready for the most ridiculous part of this whole question?
We should, man.
At rest and during flight, they mainly use fat. So they are not even really using the glucose that's in their blood for energy. They're using some of it, but it's not their main fuel source like with humans during exercise.
In what mechanism are they using to oxidize fat?
Just like us, mitochondria and everything like that. So they got the same pathways, but at rest and during flight, they're mainly using fat.
That is wild.
And we're just still trying to piece together this crazy picture.
Wow, that is insane. But it makes sense, that they would be using fat in flight.
Sure.
Because, glucose, in theory would burn way faster, and it's less calorie dense than fat.
Correct. And typically smaller things have a higher metabolic rate than larger things. By things, I mean animals. So that kind of makes sense that they're on the smaller side.
So they're just super efficient at utilizing fat for ATP.
Correct.
Huh.
And I think that's been shown specifically that there are some adaptations for that compared to birds and I think rats, that like their mitochondria are just super efficient.
Now, what are you specifically studying? Are you specifically studying like why is this going on, or do you get into the weeds and try to look for their diets and how they utilize different macros differently than other mammals?
Yeah, so a little bit of both. First, I'm actually looking on the whiteboard in front of me is an outline of my whole dissertation and all the chapters. So first thing is like we received a huge data set from the Phoenix Zoo of, upwards of 400 different species of animals and their blood glucose values. And we were able to like divide that out by birds, mammals, reptiles, and amphibians. And then we were able to divide that out by like the type of diet, herbivore, omnivore, insectivore, to see if there was any relationships there. So that's kind of one question. And also we created like a phylogenetic tree with about 140 something species of birds to see if there was like any evolutionary relatedness between birds that could explain or contribute to the blood glucose differences in species. And so far hasn't really revealed much of anything. The only thing that we can say for sure is that as body mass increases for birds, and this has been shown for mammals too, so as body mass increases, blood glucose decreases. There's an inverse relationship there, which makes sense because as body mass increases, metabolic rate decreases. So it kind of follows nicely. But while the relationship is the same for birds and mammals, again, birds, their glucose is just so high. And then on top of that, they're not really even using it too.
Wow,
so that's crazy.
That's just simply fascinating.
Yeah. So then the other thing that we're doing is we're doing a collection of three different like dietary treatments, if you will. Nothing but white bread for 4 weeks was one diet we did in birds. That paper will be published soon, but we can basically say that it basically did nothing to birds, which is just remarkable because imagine if you and I ate nothing but white bread for 4 weeks, there'd be all sorts of problems.
I think I've done that in the past.
I would not recommend it. And then we did a high-fat diet where we're still trying to piece together some of that data and whatnot. But again, it kind of looks like they seem to do just fine with that. And basically, it appears that while they're able to maintain this blood glucose without any complications, at the same time, from what we're getting so far, it appears that they can go ahead and adjust their physiology in response to whatever they're eating to not produce any complications.
Now, are you studying, or have you studied any of the, the smaller birds like hummingbirds, and they have a pretty fructose-heavy diet?
We use mourning doves, but hummingbirds are they're a little different because their diet is mainly, yeah, you're right, they're eating they're frugivorous, so they're eating just a lot of carbohydrate and simple sugars. They will use it because their wing speed is like the fastest thing seen in nature, if I'm not mistaken.
Yeah, it's the fastest muscle twitch in nature.
That's it. Yep. And so they will actually use it. So there's some differences. But when we take like larger groups and divide them up by just all the different diet types, there doesn't really appear to be much of a difference.
And, in other than this being like super interesting, which it is, what applications or how can you apply these findings to humans?
So same question. For example, let's see if they have an upregulation in some pathway that seems to protect them from blood glucose complications, from glycation or oxidative stress, whatever, right? That could essentially become a therapeutic target for a medication. So that is probably one of the quickest ways that I could see something becoming beneficial of this. And then I guess the other question is same thing with like these different dietary interventions. So we did a white bread diet, like super refined carbohydrate. We did a high-fat diet, basically did nothing. The next thing we're going to do is a Western diet. So it's going to be high glycemic index, a lot of fat. We're essentially just going to give birds French fries for 4 weeks and see what happens. And like this is just showing us that like, okay, clearly birds have like Like we use the term metabolic flexibility, but they're like crazy flexible in terms of in what we're seeing here. And if we could figure out how they're so flexible, that might help us better understand what's going on in mammals and why what the difference is and why they're able to protect themselves, whereas we develop complications rather quickly, you know? So that's kind of the application side of it.
Have you guys studied any of the like pigeons or city dwelling birds that pretty much are eating a standard American diet?
There have been some like urban ecological studies that have found like birds that are eating human foods have a higher body weight compared to birds that are in like a rural setting versus urban. So there's been some stuff like that. There hasn't been any like dietary trial like we've been doing specifically. So we're kind of like this hasn't been done yet at all. So there's just like ecological studies, seeing some interesting correlations and whatnot, but nothing like as controlled as what we're doing.
That is amazing because it makes sense that they have more access to food because people are just throwing stuff on the garbage or on the street. Don't do that, and then they eat it, and then of course they're gonna have higher weight. But do birds have heart disease?
Not like humans do. And I'm trying to think of the reasons that they die in nature are typically due to injury, is if I'm remembering correctly. So like they'll injure themselves and then they just become prey for somebody. But heart disease, no.
Because they don't have any complications from high blood sugar.
Yeah, definitely. And stress.
Well, yeah, although living in New York City as a pigeon can be pretty stressful.
I don't know. I mean, and they live in New York City and they have literally access to all the food they could ever want and no real prey hunting them. I think New York City would be a good lifestyle. That's why there's so many damn pigeons over there.
and is this basically across the board, because like we talked about like hummingbirds being, sustaining themselves purely from fructose, and then, pigeons, probably a little bit more omnivorous. What about like owls or hawks that are more carnivorous?
Just about the same, really. One thing that's kind of interesting is, so if you take birds and you take mammals and you divide them up by their diet type, so herbivore, omnivore, insectivore, yada, 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 one of the highest is for birds, granivores, and the lowest is for, is that pestivores or piscivores? Yeah, I can't read it. But either way, the range by diet type for birds is 5, right? So upwards of 20, downwards down to 15 millimole, 20 millimole to 15 millimole. For for mammals, the range is a little more than 1. So it appears that for mammals, regardless of diet type, there has to be a little more control in plasma glucose, whereas in birds, depending on diet type, there's more of a range, which I think is another interesting way to put it, because when we think about mammals, you think about humans, like we have to keep our blood glucose super tight or else we start to develop complications. And from what this perspective of diet profile is kind of suggesting the same thing for mammals. And then birds, they can kind of go ahead and still do whatever they want. One thing that's also interesting, you asked about carnivores, is we use birds for this question, but actually it's been shown that other carnivorous animals, dolphins and felines and cats, also have really relatively high blood glucose concentrations at the same time, to the point that some people suggested that we could be asking these same diabetes-like complication questions in these other mammals. And they kind of just associate like a carnivorous diet in animals typically is associated with higher blood glucose levels as well.
I have been seeing this in patients, patients that are on a ketogenic type diet for therapeutic reasons. You do start seeing, a little bit higher fasting glucose levels, or you can see A1C being a little bit on the elevated side. And I started digging in the literature, and what I found was that the glycated products that are killing red blood cells, it's a percentage of the red blood cell, so So a 5.2% A1C means that 5.2% of that red blood cell was covered on average with sugars. Okay. And when you go on a low carb diet, that A1C sometimes starts going up. And that's because those red blood cells are living a little bit longer.
Yep. So I think there's two things that are going on when you see that type of thing. You're entirely correct. The healthier the diet, the healthier the person. The healthier the red blood cells would be, the longer they can stay in circulation.
In thus having a falsely elevated, I don't know what to call it,
Yep.
A1C. Yeah.
You're correct. And actually, there's some recent literature, and I've had some debate in my lab here, specifically with my mentor about this, that like a low carb or ketogenic could induce insulin resistance.
Correct. And that's exactly where I was going with this.
Yep. So this is true, and I think what the differentiation needs to be is there is homeostatic insulin resistance, and then there's clinical diabetes-like insulin resistance. And I think what's happening when someone goes low carb is just a homeostatic insulin resistance that like immediately if they have a large amount of carbohydrates, it'll be read in like translated into the body, if you will, as insulin resistant because it's going to stay higher. But what's happening there is just the body's basically becoming better adapted to using the fuel that was already present. So when you go low carb, you're using more fat. The body's becoming a little more better adapted to that. When you give a glucose challenge, it'll be read or interpreted as insulin resistance. But still, it's not pushing towards diabetes insulin resistance, which is a completely different story. So I think when people talk about that, they need to be clear about homeostatic insulin resistance versus diabetes clinical insulin resistance.
Let's bring it back, and I'm going to tell you why in clinic I am not completely alarmed when I see this trending A1Cs up within the right context. So what the way that I explain to my patients is this: if your red blood cells are living longer, that's good. That is a good thing because you don't want to waste your stem cells making red blood cells if you don't have to, And at the same time, we are looking for this homeostatic, as you describe it, or the way that I explain to my patients is that this beneficial adaptation, meaning your body senses, oh, okay, we are being pretty efficient at burning fat in the mitochondria. Let's save this sugar. Let's not push it into the cell. Let's save it for something more important like the brain, because there is some level of in the brain that the brain needs to use some sugar. It cannot entirely function with ketones. So the body, knowing that you're not going to be receiving a lot of carbohydrates every day, starts collecting or saving this glucose in your bloodstream for when you need it. By doing this, whenever you need it, then it goes into the brain, and we can see that this is working, and this is not a maladaptive or a bad physiological response. If when you're doing your fasting blood glucose, and you are doing a fasting insulin at the same time, that fasting insulin is low, and your glucose is either normal or a little bit elevated. And that tells me that the body knows what it's doing. The reason why this sugar is circulating, it's because it's saving it for something more important.
That and the person is fasting.
And the person is fasting, yeah.
Yep. So one thing you could do, which I don't know if there's anybody who's written about this, but do you look at red blood cell count? Because if you see someone come in and they decide to lose weight and they go on low carb, and then a year later their A1C is like not as low as you would like it to be, and their fasting glucose is high, but they lost weight over this year, if you see a difference in red blood cell count, that'll kind of tell you that what you're seeing on the A1C is because there's just simply more red blood cells in circulation now compared to when they started. So that would be an interesting thing to add.
Okay, that's exactly, like I haven't kept track of red blood cell count. Another thing too is that, in theory, and this is where being pretty savvy with your lab test interpretation becomes super important, is that in theory, if you want to lower A1C on a person with diabetes, the only thing you got to do is do some blood donations. So, seriously, if you want to lower that A1C really fast, donate blood, and then you're gonna reduce the red blood cell count. You're gonna have to make brand new red blood cells, and those are not gonna be glycated.
Oh man, people listening to this, they're gonna go back to their doctor and be like, oh, they're gonna be so mad that I didn't change my diet or I didn't lose weight. They'll be like, oh, I'll just go donate a bunch of blood the week before, and then they're gonna be like, wow, your A1C is so low, you did such a good job, even though you didn't lose weight. Guillermo, you're setting them up for failure.
Well, but this is what's important. What's important is that I have heard practitioners say, oh, your A1C is high, you just need to donate blood.
I mean, I guess that would work, but
is that the outcome that we want? Is that how we want? No. Having a low number or a high number on a piece of paper without context does not equal health.
Totally. You're entirely correct. And actually, bloodletting, or donating, as you're saying, is really just one therapy that could be given, but a therapy that treats the symptoms, not the cause. So, same thing.
The symptom being an elevated A1C. And then furthermore, to make it even a little bit more, confusing, even more confusing than it is already, any therapy that lyses red blood cells, in theory, will lower your A1C. There's a really great study on how garlic lyses red blood cells and reduces A1C. So, people say, oh, garlic is so good for your blood sugar. Just take massive amounts of super refined garlic, and that is going to lower your A1C. Well, yeah, because it's killing your red blood cells.
Interesting.
Yeah, and is that why, or is that how we want to lower A1C? No, because now you're reducing your red blood cells. Now your body is going to have to waste some stem cells. Your A1C on paper is going to look better, but the only way to fix diabetes is not by trying to look at the numbers in a piece of paper. Great to see trends, and it's great to see your progress. But that number, does not mean you have diabetes or not. The most important thing you can do to change the outcomes of diabetes is to change your diet. I tell my patients that I don't treat paper, I treat people.
Great way to say it, yeah.
Yeah, being able to understand the nuance, because I do see patients that, that come in and, start hearing about a cleaner diet, and it doesn't have to be keto, and then they get concerned because that A1C is kind of going the wrong way. That's not to say that there are some reasons why the A1C can go the wrong way that is not beneficial, and there's some reasons why the A1C can go down and it's not beneficial. But you have to have the context. A1C as an individual marker, it's a great screening tool for populations, but from case to case, you really need that fasting blood glucose. I've been reading a little bit about fructosamine. That's another great marker. And then, getting a quick check, glucometer, and seeing your postprandial, or, how your sugar goes up and down after you've eaten, and how it goes back to baseline, or it takes 6 hours to go back to baseline. That would be the most important way to gauge health.
What you're saying about A1C is entirely correct, and it's kind of also the same thing about BMI. It works well for larger populations, but individual people, it's not exactly the best measurement of body weight because it doesn't account for different differences in frame or muscle mass and everything like that too. So,
I've been, it's so cool to talk about this. Like, I don't think I've ever talked to this about this on the podcast. And the first time that I ever started looking at A1C and insulin response was about 6 or 8 years ago when I was working at the hospital. And I was talking to one of the nurses, and pretty active, very healthy, and she was pregnant with her second child, and she was going to do that fasting blood glucose challenge. to see if she was pre-diabetic. And she was like the picture of health, very healthy pregnancy. And with her first child, when she did this challenge, where they give you like 100 grams of sugar, her body was not reacting and lowering that sugar. And her OBGYN told her, you're pre-diabetic, and she was devastated because she had been the picture of health for so long, and now all of a sudden she gets pregnant, and now a doctor's telling her that she's pre-diabetic. And she was like, pretty sad during her second pregnancy because A, she felt like shit when she did that fasting blood glucose, and B, she didn't want to be pre-diabetic. So like about a couple of weeks before she was due for her test, I was like asking her questions. We're just bouncing out ideas, and she was like, yeah, I try to eat. I don't eat a lot of carbs. Especially at night. And I was like, wait a minute. I think what's happening is that you're giving your body 100 grams of sugar, and your body doesn't know what the fuck to do with it. So a couple of weeks before she went and had the test, she started eating sweet potatoes at night.
Some more carbohydrate.
Yeah. So at night, like for dinner, she would have a huge, like not those small sweet potatoes that you might get at Costco in a bag. No, I was like, you need to go to like Whole Foods and get those pounders,
The size of a shoe.
the size of a shoe. Put some cinnamon on it, and guess what happened when she tested that fasting blood glucose with 100 grams of sugar?
Much better.
That insulin response was perfect.
That's awesome. The doctor didn't say anything about gestational diabetes or anything when she was pregnant, because typically that's why they do this.
Totally, that's what she said. That's what the doctor said. You have gestational diabetes.
Oh, I'm sorry.
It didn't make sense in my head.
Yeah, so that's they're still not sure exactly why that happens, but they do know that when a woman has gestational diabetes during pregnancy, that child is then more likely to develop type 2 diabetes themselves. But I believe, and actually this is an interesting evolutionary medicine question, preeclampsia and gestational diabetes are some very common questions that people try to think about from an evolutionary perspective. Why would this happen in the mother, for example, when they become pregnant? What is actually happening here, and why is that? I forget where the literature stands on that right now, but that's a super interesting question. And I think you're entirely correct with what that woman did.
And then, I have been reading about thyroid disease. And curiously enough, thyroid disease is usually presents itself after a really massively stressful period in life, and usually in women is after they give birth. Yes, after childbirth. But it doesn't have to be childbirth. It could be like a traumatic event, like the first Graves' disease. That's autoimmune hyperthyroidism that was ever the second actually that was ever described in the literature was a person that fell down the stairs, and so that can be pretty traumatic. Ended up in a wheelchair, and then the Graves' disease manifested. And I imagine that the reason for this is because of the amount of stress in the body, and it goes back to it's not only stress that we that we can physically perceive. It could be also mental stress that could be triggering this pathways that are pro-inflammatory. So having high glucose levels in the body could be like, or having a lot of stress could be the straw that breaks the camel's back, that increases your glucose levels in your body. But as we've learned from birds, that's not a thing. Having high glucose levels in the body could be non-stressful at all.
For them, I mean, they've had millions of years of adaptations to help them.
What are you talking about, man? 6,000 years. But yeah, it's super interesting because whenever we think we figure something out, like I can imagine, like the scientist that says, what, we can average the 3 months of your glucose levels in your body by measuring the glycated products in red blood cells, and eventually it gets to to practice, and now you have doctors saying, oh, you just need to have some blood draws, and then that will fix your A1C.
Yeah, it's a bad way to go about it, though.
Now, before we started this conversation, we are talking about like a pretty epic paper that was published 5 years ago. Can you tell us a little bit about that?
Yeah. Okay. So this was a paper done by Hamilton Staple from SUNY New Paltz, SUNY State University of New York, New Paltz, and he and his colleague on the paper conducted a survey of the paleo community, and the results are published in the Journal of Evolution and Health. If you want to go check it out there. If I remember correctly offhand, it's Stereotypes and Realities of the Ancestral Health Community is the title of it. And they got a super large sample size of about 4,000 people over the course of like a little less than 2 weeks. And they promoted that just online via social media, and people shared it and retweeted it and stuff like that. And they got a great sample size. And they found some pretty interesting results when they did that. So those are all published, and you can check out them. But currently, I just joined the project, and they're doing a follow-up survey 5 years later of the paleo ancestral health community to see what has changed over 5 years. So that was actually just launched today online. So you may have seen that in various places on social media. And actually, if you don't mind, Guillermo, I'll give you the link for that you can put when you post this podcast. That'd be great.
Oh, no, totally. And let me ask you, what were the findings on that first round?
Oh, I'd have to pull those up if you want to give me 1 second. I am very interested. I'll keep talking while I pull it up, but I'm very interested to see how things have changed since this period of time, over 5 years.
In the past 5 years, the definition of paleo has changed dramatically.
Definitely. So the title of the article is Modern Caveman, Stereotypes and Realities of the Ancestral Health Movement. So let me see. I'll just pull up the abstract here. Despite the common stereotypes, survey evidence suggests that the majority of participants are white, female, middle-aged, in a committed relationship, highly educated, relatively affluent, and motivated by weight loss and health concerns. Thus, while some common preconceptions may hold up, many others do not. Yeah, 40% of the population holds a master's degree. The largest group, 21% of the population, was making between $100,000 and $150,000. Largest population that took this, 15% of the participants were from California, then New York at 7%. Let's see, most people went in, because of weight loss. Next to that was 21% of the participants went in because of recovery from illness. People listed primary obstacles for living a paleo diet, and 23% said social pressure, and 21% said giving up favorite non-paleo food. When asked how hard is it for you to maintain a paleo lifestyle, the largest group reported easy, 27%. This is interesting. So 5 years ago, how long have you been living a paleo lifestyle? Again, remember they had over 4,000 participants in like less than 2 weeks survey promoted via social media. 36%, more than a third, were only following paleo for 1 year.
Wow.
Yep. And that went all the way up to 4% more than 5 years. So when this survey was conducted, I've been talking a lot about this with Hamilton. This survey was conducted really during probably the most popular period of time for paleo diet. Some of the other things they found was, which of the following do you regularly avoid? 98% avoided grains, 88% avoided legumes, 39% avoided dairy, and 43% avoided alcohol. So it looks like more are consuming alcohol and dairy, less are consuming legumes, and then like a very small amount are still consuming grains as well.
I wonder if people that are doing like a ketogenic diet and they're doing it appropriately, where they're doing like a ketogenic diet that is based on animal products and, unprocessed, unrefined foods, I wonder if they're going to be dissuaded about answering these questions because they are not paleo, they're keto.
This is something we thought about too. Again, how people identify themselves as their diet specifically has changed. I think that Whole30 doesn't specifically align with paleo, so a lot of people could be doing that, even though it's basically a paleo template. And that's a pretty damn popular diet as well. So it's going to be interesting to see, A, how many people respond to this survey and do it, because we're trying to keep it the exact same distribution as last time. And then B, where does it vary? So it's really interesting. So yeah, if anybody's listening and you follow a paleo diet, please complete the survey.
What if they follow like a keto paleo diet?
That's fine. Yeah, as long as some part of their diet, how they identify their diet is paleo, they would be fine to do the survey.
So you heard it here first, guys. If you identify as a paleo practitioner, we're gonna have the link, and this is super important, and this is we do get a lot of pushback from the scientific community, interestingly enough, about how one of the worst arguments that I hear about the paleo diet is when people say, "Oh, it's impossible to be paleo because we don't live in a Paleolithic environment. So unless you go and buy and kill your own bison, you're not eating paleo." Well, that is like a very soft argument against the paleo diet, because we're not trying to recreate the Paleolithic lifestyle. We're trying to learn from evolution, and we're trying to look at our physiologic adaptations and try to adhere to the best diet that we can with the tools and the resources that we have. And whether that looks to you as a autoimmune paleo diet, whether it looks for you as a keto paleo diet, or a Lauren Cordain approved paleo diet, it's very important to see the reasons why, and then outcomes, and really start creating some body of evidence to help us guide the best practices for nutrition. Because as of now, the only, the main mover in our nutritional recommendations, I could argue, is profits. And unfortunately, it's really difficult for large corporations to make money out of unprocessed foods, and thus we are in the conundrum that we are. But so if you have benefited from a paleo lifestyle, from a paleo diet, go ahead and put in your 2 cents, and let's try to get some information out there to help us promote this movement.
Yeah, survey takes literally just about 5 minutes to complete, and yeah, I mean, we need to, and actually Hamilton Staple has written about this a lot, about what he sees as the future of the paleo movement and stuff like that, and he's got some very interesting views on it. I have recently been thinking a lot about this question and the pushback, and what does evolution actually inform us about diet, and I'm still developing my exact stance on that, and actually it's going to be part of my dissertation here for my PhD as well. But yeah, I mean, it's an incredibly complex field. What goes into what somebody eats, there's a lot of different inputs that go into what somebody eats and what ends up actually on their plate. It's actually partly why I love just nutrition itself. It's incredibly complex, and you can slice and dice a diet so many different ways, and think about food and whatnot. So yeah, I love it.
Can you tease us some of your ideas on what it means and how it's going to pan out?
I think the paleo diet perspective is missing what is actually going on. That's all I'm going to say. You'll have to interview me again. You'll have to interview me again in a year if you want more details on that. Actually, I was supposed to give a talk at AHS this year, but unfortunately I was unable to make it. I had a death in the family. But I was going to talk about this exact thing, and I think that you would have really enjoyed the talk.
Yeah, and it's so difficult. It's so difficult to
incredibly difficult,
because if you say something like, oh, like I remember back, I don't know, 5 years ago when people start talking about how legumes could be part of a paleo diet. And more specifically, if you follow Whole30, if you ever did the first version of the Whole30, white potatoes were not allowed. And it was just this random crazy rule: white potatoes are not allowed. And then Melissa in Dallas, after much research and deliberation, and very healthy people that are like, yeah, I eat potatoes, they decided to include it, and there was some pushback.
I remember when that happened.
Yeah, and there was some pushback. I was like, what do you mean? You guys are selling out to big potato. Like, what? And I think that if there is a problem with the way that we consume food, the way that we process grains, and the subsidies with grains, and how they push for a narrative that might not be the most healthy, and sugar, and the way that we utilize sugar, and the way we promote sugar, and that is a huge problem. But there is also the problem of the people that have become a little bit orthorexic, and then and have aversion to foods, and are making themselves sick just by thinking about the bad foods that they're eating, and they cannot enjoy a normal lifestyle, because they think that if they put a white potato in their mouth, they're gonna I don't know, melt like the Wicked Witch. There is some leeway, and I think that leeway is going to correlate to the level of health that you have. Or maybe I'm completely wrong, and maybe no one should eat potatoes, but having a little bit of fun, and having a little bit of metabolic flexibility, to where if you're keto, eating a baked potato is not gonna sideline you for a week. And if you are a high charging athlete, that is trying to keep glycogen levels pretty high, and you miss a meal out of your 6 meals, you're sidelined for a week. There has to be some metabolic flexibility on both sides of the wall.
Yes. I agree. And Laura Schoenfield, who's a registered dietitian, she's actually talked a lot about this, and how I think what is even more interesting, besides how incredibly complex it is, for somebody's diet to actually become what they eat, and how food ends up on their plate, is even more how complex is how lifestyle and diet influence health. Like, eating is just really one input. It's a very important input, but there is so much more to the picture. And that's one thing that's really nice about the ancestral health perspective, is it's not just food. And, you go to AHS and they talk about pretty much everything, because really you need to incorporate every aspect of your life to promote health, to be healthy.
And just to circle back around to that, just a second ago, when I was talking about, or trying to get people to sign up for the survey, I mentioned a paleo lifestyle, and I kind of corrected myself, and I said, if you eat paleo, because it starts with eating unprocessed foods and trying to eat like a caveman. But after a couple of months, you start using a standing desk, and you start sleeping better, and you start incorporating more movement, and doing all of these things. So it's forever going to be confounded. What is giving you health? Is it the fact that you decided to not eat fast food anymore, or is it all the little incremental changes that are more evolutionary adaptive, or align better with our evolutionary adaptations that are creating this health?
Definitely. Outside of your podcast, if you want to talk more about my dissertation, I'd be happy to chat with you about that.
You just don't want to get kicked out, or don't want someone to scoop you.
I'm sure. Yeah, that's a major problem. Circling back to Whole30, I think what's really interesting about Whole30 and the way that they execute. First of all, I haven't read many diet books in a while, because I'm kind of past that in terms of my nutrition understanding. But I think the It Starts With Food book is one of the best food diet books that I've ever read, particularly because of how they address one's relationship to their food and their diet. It's very, very cleverly written in the book. But one thing that I think is very interesting is, people go through the Whole30, and I think what is really happening is probably what's going to be responsible for some of the most long-term benefit from the Whole30 is they're really resetting their palate, right? They're getting rid of junk food essentially, and they're getting 30 days is pretty decent to get past it. They're developing new habits, and they're changing what they're identifying as food. And then they go through the process of reintroducing stuff like that, and then they see, oh, this actually doesn't make me feel good. I don't feel well when I eat this, and then they kind of figure out where it works for them. So essentially, they're just like pushing away the standard American diet for 30 full days, then reintroducing things and seeing how they work. And I think, yeah, a palate reset is really what's going on there.
And the same phenomenon happened with me many years ago. When I was in my early 20s, the first time I decided, like I'm getting a little fluffy, I need to start, doing something about my diet. And I did like a South Beach, diet, which was a lower carbohydrate diet, and it worked. And I think that was my first impression or my first bias towards trying to consume a lower carbohydrate diet for weight control. And those lessons stuck with me, and I was eating like a dummy, fast food morning, evening, and night. And then all of a sudden you go into,
I miss those days.
yeah, into a more of a Mediterranean approach. And I was still eating wheat. I was still, eating fat-free cheese. But I had some results in the next, in after I got tired of the South Beach diet, anytime that I needed to lose weight, then I was like, okay, I need to go on a low carb diet. And those lessons remain with me. And thankfully, I ended up in this evolutionary medicine track of things. And now I don't have to cyclically adhere to diet. I can maintain my fighting weight without much change into my daily routine. But those lessons definitely stick. So yeah, doing something like a Whole30 and that being your first introduction to your diet, to a diet, it's not only powerful, but it's indelible. Those lessons really stick with you, and you notice why you should be, adhering to this unprocessed diet.
It's the perspective of it's not a diet, it's a lifestyle change, right? And then circling back to before, you were talking about subsidies and foods. It's unfortunate because foods that are subsidized in this country directly feed into junk food. Wheat, corn, and soy becomes bread, high fructose corn syrup, and soybean oil, which is added to everything and relatively shelf stable. So essentially, the government, the way I see it, is essentially funding the obesity epidemic. And I had a great talk the other day that I went to, and the presenter was saying that we need to make a healthy diet and physical activity the norm in this country, because that's what's completely missing. And I think the way that we do that is going to be through policy in terms of politics and getting the government to address these issues like the subsidies and calorie labels and restrictions. And people have different stances on like the soda or sugar tax and whatnot. But like, I don't think we're going to be able to get out of it when people are still trying to profit off of our sickness.
And it's very noticeable from like the results that from the previous 5-year paleo survey, affluent, well-educated, and it's sad, because I want this to be a diet for everyone, not just for the elite.
Totally. Yeah, I mean, I haven't looked at these results in a while, but yeah, the large amount we're making, let's see, 2030, about 40%, 50%. 50% of the survey participants were making more than $80,000 a year. And there was a study that came out not too long ago and found that to consume a diet, a paleo diet, and then a diet matched for micronutrients that didn't come from paleo foods, that came from non-ancestral foods, it was 11% more expensive to have a diet that was matched for micronutrients coming from paleo foods versus not.
Wow.
And to be fair, that's just the nutrient perspective, though.
That is just a nutrient perspective, and you can see it because you can get pretty crazy with like Soylent or different shakes and stuff like that, and you can just eat a damn steak and you'll be fine. And no, not even steak. You can even do like organ meats, and which is even cheaper than steak, and be all right. So what I've learned with this conversation is that we gotta be more like birds. We gotta be adapted to use only our sugar when it's completely super necessary, and if we want to fly, we should start being keto. That's pretty much what we talked about. So you don't just fast forward to the end of the conversation, listen to this last 30 seconds, and then we won't bore you.
How much time do we have?
Oh, whatever you want, man.
Whatever we want. Okay, because there's my recent publication that I would love to chat with you
let's talk about that. Yeah, let's talk about that.
Yeah, totally. So I finished my master's at this point. Wow, 3 years ago, master's in human nutrition. And when I graduated, I was like, man.
You heard it here first, guys. Anthony Basile is a master of human nutrition.
Thank you. It's pronounced Basile, by the way. I don't know if I've ever.
Is it Basile?
It is Basile.
Oh,
yeah.
dude, I don't even know who the fuck you are.
That's okay. Yeah, we're practically neighbors, and you can't even. I'm just kidding. Yeah, so I graduated with my master's, and I was just like, I am all about this evolutionary perspective and evolutionary medicine. Like, it'd be very interesting to see what other people in nutrition and dietetics think about evolutionary medicine. So I was like, all right, I'm going to do this. And then without any funding, I was able to get like 3 other people on the project who were a tremendous help. And we created an online survey, distributed it online to many of the nutrition and dietetics groups, the nutrition and dietetics education programs, and to a collection of nutrition and dietetic professionals. And we basically sent them a survey that like, hey, what are your thoughts on evolutionary medicine and its application to the field of nutrition and dietetics? We ended up getting close to, I think it was a little more than 2,000 participants, which was pretty remarkable for an online survey, and I was extremely happy with that. And we found some really interesting things. And if you want, I'll go ahead and just run down some of the main findings here in the abstract.
Go for it.
So close to roughly 60% of the participants, so these are students and professionals, about 2,000, agree that they are knowledgeable on the theory of evolution. Yet when we asked them to define the theory of evolution, they gave like not very scientifically based definitions. On top of that, they, again, close to 60% felt that an understanding of evolution can aid the field of nutrition and dietetics. And then specifically, 51% of them thought that an evolutionary perspective would be beneficial within dietetics education. And then one of the most important findings was that 71% of the participants found that stated that it was equally important to understand both the evolutionary and the direct cause of disease. So direct being mechanism, what is happening, and then evolutionary being why. Why is this the disease why do humans have the ability to develop this disease in the first place? So I thought that was really interesting. So overall, we can say that there appears to be some support within the groups, within the participants. And actually, we cut the data in half and compared for differences, since we had such a large population, differences between students and professionals. And without going into the nitty-gritty, basically it appears that students right now, so students which are going to be the future professionals and practitioners in the field of nutrition and dietetics, they seem to be a little more supportive of evolutionary medicine, and they also appear to be learning more about evolution compared to professionals who graduated roughly 20 years ago. However, still, both groups, while they said they were they had a definition of evolution, when we asked them to define it, the top 4 most common words were change, time, survival, and adapt. And natural selection existed in 11% of the definitions, survival of the fittest existed in 9%, and the phrase change over time existed in only 6% of the definitions. And then on top of that, we asked, are you actually being taught this? And
23% of the total population said that some conversations about the theory of evolution incorporated aspects of health and disease. So still very small amounts.
So what is the most scientific way of describing an evolutionary diet? Or let's not say scientific, the most accurate way.
Sure. So within evolutionary medicine, there are several different ways that you could examine disease. And it's basically going to be, I like to frame it from the evolutionary mismatch perspective. So that being that we have genes that are adapted to a specific environment. The environment has changed quicker than our biology and genes could essentially catch up. And then associating that change in the nutritional environment with a lot of the diseases of civilization that we see today. That's typically how I like to think about it, and I think that's really the best way to apply an evolutionary perspective is say, okay, we have a long evolutionary history. Homo sapiens have been around for a long time, and this diet that we eat today is like a drop in the bucket of our evolutionary history. And what can we look at in terms of how our diet has changed and the disease that we have today at the same time. And again, disease is much more than diet. This is just one perspective.
Yeah, because I just you reading that that definition, I don't know if I would have used those keywords this in describing. I understand those concepts, and I present at at the Ancestral Health Symposium, which is all about mismatch. And I don't think I would have said change over time, and I wouldn't say those keywords that would put me in the scientific definition, even though I understand it and I agree.
Yeah.
That is fascinating.
I'm taking a class on principles in evolution now, and it is an incredibly challenging thing to fully understand, and for a lot of things, such as how do you classify something as an adaptation? There's no one direct answer. So it's really interesting. It's kind of like how do you define a gene, right? There's no specific definition of what a gene is. And also, same thing with a species. How do you define a species? There's really no clear cut. I think I remember reading somewhere that there's like 40 different ways to define species. And again, this is all just because we are trying to take our human brains and understand something as incredibly complex as life and nature. And we're trying to categorize it, and really, you can't categorize anything. And I think it kind of lends itself nicely to, when you look at somebody, when you have a patient come into your clinic there, you look at them on the outside, they look healthy, and on the inside, they're all sorts of messed up.
Or the other way around.
And the other way around, too. There's actually some very interesting research going on at Mount Sinai, St. Luke's Hospital, and back in New York City, where I worked before I came here. And Rich Weil there, he runs the weight loss clinic. He's doing some incredibly interesting research in the morbidly obese, like class 4 and class 5 obese, who are completely metabolically healthy. And he's like, what is going on here? How is this possible? And he's asking some really cool questions. And actually, I have a question for you based off of this survey. So we basically divided up the questions in terms of evolutionary education and understanding. So that I kind of talked about. Then we talked about evolutionary application, and I kind of introduced those already. We had a little section that talked about clinical applicability of evolutionary medicine. And 46%, so just a little less than half of the participants, responded that they were unlikely or very unlikely to provide an evolutionary explanation of a condition or a disease to a patient or client. And I'm curious, do you go to that in your practice often?
All of the time.
All the time.
All of the time. And, one of the easiest examples is talking about lactase prevalence and why someone would react to lactose. And then, interestingly, we did talk a little bit about thyroid disease, and how that's an autoimmune condition. And I do go a little bit into evolutionary theory when it comes down to talking about why is your immune system betraying you and attacking your own tissues. I'll talk about different adaptations when it comes to your. Have you ever read the book An Epidemic of Absence?
No, but that has been recommended to me before, and I should check it out.
Yeah, yeah. So how we live in very clean environments, and our immune system, kind of was used to being on the lookout and attacking pathogens all the time.
Sure. Yeah, I'm familiar with that concept.
So now that we live in a super clean environment and no longer living in farms, or even before that, just roaming the earth, our immune system is bored. And now all of these insults, whether it's endocrine disruptors, or the food that we eat being a little bit more allergenic, your immune system goes haywire and it starts attacking you.
If I'm not mistaken, that's called the old friends hypothesis.
All friends hypothesis, yeah. And so I use it all the time, because people are. It's easier for me to convince someone to adhere to a protocol if the answer to their or the explanation to the disease process is more than random luck.
Interesting.
Yeah.
I'd be very interested in talking more with you about this at a later point, because that may end up being one specific area of my dissertation.
And have you read Rob's new book?
No, actually.
It starts with "It's not your fault." It talks about like all of the different things that companies have done in order to make food more palatable, and all of the different social pressures that are in place to make food more palatable, and how you're fighting a losing fight against evolutionary adaptations. And it's not just like, oh, your grandma was fat and and that's why you're fat. No, it's not your fault. It's actually all of these outside pressures. And if you understand those outside pressures, then you have a fighting chance.
I think also, as soon as somebody recognizes that the person with obesity or the person with diabetes, they didn't cause it themselves and that they're a victim, it really just changes the whole way that you perceive the disease. And like, if somebody saw it otherwise, I don't even know if we'd be able to have a conversation about the disease that would go anywhere, because they would just see it as, this person's lazy and they can't control themselves, which unfortunately was a lot of how obesity was viewed 20, 35 years ago,
And there are accidents, there, you can get run over by a bus, or you can, you can get into an accident, and that's just random luck. But for things that are progressive, such as, autoimmune disease, or obesity or diabetes, things that can be preventable, if you don't understand the reasoning why, then it is a losing battle, and it can be very frustrating. So yeah, no, I do pull those very powerful lessons, and they seem to get a lot of traction with my patients.
Excellent. Yeah, I mean, as soon as you're asking why questions, if you're talking about any why question in terms of biology, you're talking about evolution.
Yeah. So what I've learned, like I said, is like let's be like birds. Let's try, let's try to save our sugar for important things. And Anthony, Basile, where can people find your work? Where can someone find your papers? Where can people go and get those that survey filled out?
Sure. Yeah, I'll give you all the links. If you want to find the survey right now, immediately, Rob Wolf posted a blog post about it, so you can find the links and stuff there. I'm on Twitter. I'm trying to step up my academic Twitter game. Not doing very well at that, but it's Anthony Basile, Anthony Basile, Basile 88. So you can find me on Twitter. And I'll give you the link for. I pulled up 4 links for you here: my Twitter, the lab that I'm in at ASU, the Ancestral Health Society, and then this most recent publication that we just discussed.
And I promise you that after this podcast, at least you'll gain at least 4 more followers.
Excellent.
Guaranteed.
I'll keep an eye out for them.
Dude, so awesome to have you in town, and we got to go get some tacos one of these days.
Yeah, seriously. Paleo tacos.
Yeah, 100% paleo, non-GMO tacos. Uh,
Exactly.
yeah, and so awesome to have you. And like you said, let's get that. As soon as you get that dissertation defended, let's get you back on the show and let's continue geeking out on this crazy topic.
Definitely.
Awesome, dude. Talk to you soon.
Great. Thank you so much. Take it easy.